This is an optical element. So using this element, you are going to learn how the light rays behave. You can have some kind of expertise using prisms. When light rays incident on a prism, they are submitted to refraction, reflection, those kind of stuffs. So you can develop your understanding of that geometric optics parts using prisms. That's why we specifically learn about prisms here, right? Okay. So the first thing is you have to clearly understand the shape of the prism. No, usually in O-level times, you have learned that a prism has two triangular shapes, right? Two triangular shapes and three rectangular shapes. It is like this. So I can show one triangle like this. You can draw it with me. One triangle like this. Then the another triangle behind it, right? So what is behind, I'll draw that in dashed lines. So there are two triangular shapes, right? At this one and this one. Then there are three rectangular sides. So that is how the prism is consisted of, right? Then whatever, let's say you place this on a table. The face of the prism that you place on the table is called base. You need to remember these names as well, right? So before learning the behavior of light, you have to know everything about the prism. So this face is the base, right? You can take notes with me. This face is what we call base, right? If you want, you can place the prism on the triangular shape as well, triangular surface as well. Then this is called the base. But here, base is like this, right? Then this end, this top end, we call that apex. So that's why this angle is called capital A. We call that angle prism angle, right? You need to know these names: prism angle, or sometimes we call it refracting angle. Prism angle or refracting angle. Okay? Usually, here what we learn mainly is a light ray, about a light ray that is incident on this surface. You have to imagine that surface, right? Behind it. A light ray hits this surface and leaves from this surface. So this surface, we call that, I think you can understand, this is actually behind it, right? Refracting surface. First refracting surface. Then the light refract from this surface as well. We can name it refracting surface 2, right? The first refraction happens at this surface that is behind, and second refraction happens on this surface. Okay, I think clearly now you understand that, right? You know, when you have the prism, right, it is it's like this, right? This shape is the prism. So a light ray hits on like this, perpendicular to this refracting surface. This is the first refracting surface, second refracting surface, and you have the base here, right? So we are learning about a light ray that is incident like this. Must be perpendicular to this surface. Otherwise it is complicated, right? In the syllabus we only learn about light rays that incident on the refraction normal to this surface, right? Then it emerges, the light ray emerges from the other side. So first refracting surface, second refracting surface. So then we can draw a ray diagram. That ray diagram is drawn on the principal plane. You need to understand the principal plane. Principal plane is a plane that is, if you cut it like this, you are drawing everything that is on that plane. As you understand that, we can show it here like this. Use a different color. Right? We call this principal plane. Right? So we draw all the ray diagrams on the principal plane. Okay? I think everyone understood that. Okay. Take it down. I think if you have any problem, let me know. Right. I think completed, right? Thumbs up if you have completed this. Right. Below this right, consider a monochromatic light ray. Consider a monochromatic light ray being incident on a glass prism placed in air. Okay. So this is important, really. So what I am drawing here is the principal plane actually, right? Principal plane. So I can draw it like this. You can draw it with me and draw it a little bigger, right? This is the principal plane. This is where we draw the ray diagram. Okay. A light ray is incident like this, right? This is called incident ray. So whenever that is the case, then there's a refraction. You always draw this normal, right? To figure out the direction of the light ray after refraction. So usually this is air, right? Refractive index 1. Let's say this is a glass prism, right? Then this is the dense medium, so the light ray was going to go like this, right? But it bends towards the normal, perpendicular. Then it will move like this, right? Again, draw a normal, like this, right? Now the light ray is moving from a dense medium to a rare medium. So what should happen? It was going to go like this, but it bends. Now it bends away from the normal. Let's say like this. It bends, right? Then here we have the prism angle A. You can extend these rays. I'll extend this like backwards, like this. And this one also. These are the two normals, right? I'm going to extend those as well. Okay. So from a side right, let's say this is simple A, we call that, these names are important, right? This ray is called incident ray. Then we have this ray, this we call a refracted ray. Refracted ray. Then this ray is called emerging. This is emerging out of the prism, right? So it is called emergent. emergent ray. Emergent ray. This simple M is refractive index of the glass, right? Simple M. I think you need to complete this. Okay. Okay. Then I'll fill these angles. The angle that makes it the normal, this angle, we can call this I1, right? It is incident angle. Then the normal makes with this ray, that is called R1. We call this refracted angles. Then this normal makes with this ray, that is R2. That also we call a refracting angle. Then this angle that makes with the normal here, we can call that I2. You have to name it exactly like this, right? I1, R1, R2, I2. You have to clearly understand those angles, right? Every angle is made with the normal, right? Normal and the ray. This is the normal and the ray. Normal and the ray, right? So we have I1, R1, R2. You need to identify these ones. Take it down. I1, we call this incident angle. Then R1 and R2, R1 comma R2, those are called refracted angles. I2 is called emergent angle, right? So those names you need to remember. I2 is called emergent angle, R1, R2 refracted angles, I1 incident angle. Okay. So this is the first thing, right? Then you need to write some equations between these angles, I1, R, these ones, R2, I2, right? Think about this one, right? The ray was going to go like this and it has bent here. It is bent by D1 amount. D1 amount. This is called angle of deviation. So this is deviation by the first surface. At the first surface, this is deviated by D1 amount. Okay. Then at the second surface, the ray was going to go like this. Then it has bent this much. So this is what we call D2. You can see this D2 and this rays. So we can say this also is D2. This angle also D2. Here we have D1 and then D2. Okay. Then this angle, the ray was going to go like this and as it emerges, it has bent this much. So we can say this is the total deviation, right? This D is the total deviation. Using a geometric theorem, you can understand this D1 plus D2 is equal to D, right? So that is the total deviation. Simple D is the total deviation. D1 is first deviation at the first surface. D2 is deviation at the second surface. Here, for D1, we can write this equation, right? For D1, what is D1? So this whole angle is I1. If you subtract I1 from R1, I mean R1 from I1, then you can get D1. So this is I1 minus R1. I1, this is I1 minus R1, that is D1. Then for D2, D2 is here, right? That is, this whole angle is I2. This angle is I2. I2 minus R2, that is going to be D2. So I2 minus R2 is D2. So you should be able to derive these on your own, right? These are not complicated. Okay. So this D1 and D2, deviation at first surface, this is deviation at second surface, right? Then there are a bunch of equations that you need to remember. Write down note, write down note. Okay, you can take this with me, right? Then write note. Under note, first one you need to remember this equation. Prism angle or the refracting angle capital A is equal to R1 plus R2. First equation you need to remember. R1 plus R2 is equal to capital A. You can see it here, right? According to geometry, so when you consider this this shape, then you get this angle should be capital A. We can prove that. Okay, this angle should be capital A. When we consider this triangle, then R1 plus R2 is going to be equal to capital A, right? So that is the first equation you get. Prism angle is equal to R1 plus R2. You need to remember these. Okay, so that is the first equation. Then the second one is simple D is equal to D1 plus D2. See here, D equals D1 plus D2. But further I can derive this. D1 is what? I1 minus R1. D2 is I2 minus R2. Then I'm going to take I1 here and plus I2. Then put a minus sign, then you can get R1 and R2. R1 plus R2. Right? Then what do you get? D equals I1 plus I2 minus. What is R1 plus R2? That is capital A, prism angle. So you have capital A here. Then I am going to take capital A to this side. D plus capital A is equal to I1 plus I2. This is the second equation that you have to remember. So we have R1 plus R2 is capital A. I1 plus I2 is what? Capital A plus simple D. Simple D is the total deviation angle, right? Angle of total deviation, right? So this is the first one. This is the second one. Right. Okay, right? So everyone clear, right? If you have any problem, let me know. Okay. So when we are solving problems, you will have to use these equations, and there's a one more equation. So there's a refraction happening, right? There's a refraction. So for the refraction, you can use Snell's law. So the last class we discussed Snell's law. That's the third equation. So what's the Snell's law? N sine theta is a constant, right? So any of the problems regarding prisms, you can solve using these three equations. So if n sine theta is a constant, let's say you are applying that here. So the refracting index is 1. 1 times here the angle is sine I1 equals, here refracting index is n, sine, this angle is R1. Okay. You don't have to remember this, but you can just apply Snell's law here. Okay. Snell's law. So those are the main equations that you have to apply in order to solve problems. Okay, I think everyone got the notes, right? Okay, to solidify this knowledge, we'll do a simple question, right? Write down, put Q, and write down find emergent angle, emergent angle within brackets I2, emergent angle within brackets I2, and angle of deviation, angle of deviation within brackets simple d, angle of deviation simple d, angle of deviation simple d, and within brackets it is given n equals 1.5, capital A equals 60 degrees, that is prism angle, and I1 equals 30 degrees, I1 equals 30 degrees. Okay. So for these ones, you have to find that this equation, just to familiarize you with the equations we derived, right? You can directly use those equations. Okay. So R1 plus R2 equals A, one equation. I1 plus I2 equals simple D plus capital A. Then Snell's law, right? Okay, using those, you have to find that. First, you need to find I2, then you can find angle of deviation, simple D, right? You don't have to draw it. We have already drawn it. So looking at the that one, uh, try to find that. First find I2, right? Don't have to draw anything, right? You already have the image on the note. So I1 is 30 degrees, right? This is incident angle. And prism angle, we know that 60 degrees. R1 plus R2 is equal to A. Another one, I1 plus I2 equals D plus A. And the Snell's law. So we can directly use these now. I mean, you can, but you can see after that we cannot do anything. First thing, you need to find this R1. You need to find this R1, right? How to find this R1? You have to apply Snell's law to this position, right? So how do we apply the Snell's law? Refractive index is 1 air times sine 30 equals, here the refractive index is 1.5 times sine, this is R1, right? So you have to simplify this and find R1. So at the last class we discussed how to find those sine values. You can use it here, right? So sine 30 is 1 over 2. 1.5 you can write it as 3 over 2 sine R1. This 2 cancels off, then 1 over 3 equals sine R1. You don't know the value of 1 over 3, right? So you have to refer the logarithm book. So you have to convert this into a decimal, that is going to be 0.33 something, right? 33, this is equal to sine R1. So R1 is equal to sine inverse 0.3333. Okay, you need to practice this. Okay, you need to practice how to find this. You learn this in A level, sorry, O levels. Someone tell me the answer. What do you get at sine inverse 0.33? So you need to have this book, right? Okay. So you have to find from the middle of the book, right? From the middle of the book, this value or a close value to this. So what do we have? 0.333 something. We have 0.3311. Okay. There's 22 missing. You need to find 22 somewhere here. Okay. So for this value, what are the angles? You can read it from here and here. We have 19 degrees here, and you can read minutes from here. We have 20 minutes. Then for 22, you have 8 minutes. You need to add this to here. Okay. So when you take the inverse of this, what do you get? 19 degrees 28 minutes. So that's the value of R1. So when you are learning this, you need to find these angles, right? You should be able to quickly find these. So for that you need practice. 19 degrees 28 minutes. So that is the R1, value of R1. Okay. So that is the value of R1. If you know R1, the other thing you know is you know the value of R1 plus R2. R1 plus R2 is prism angle, right? So prism angle is 60 degrees. R1 is this much. 19 degrees 28 minutes plus R2. So now you can find R2. Okay. So if you have any issue, let me know. Right. So what is R2 is equal to 60 degrees minus 90 degrees 28 minutes. Okay. So you should be able to do this subtraction. So how do we do that? This 60 degrees, you can write it as how? You can write it as 59 degrees and 60 minutes. You know that 60 minutes is a 1 degree, right? So if you want to do this subtraction, you need to write 60 degrees like 59 degrees and 60 minutes. So it is, when you add these two, it is 60 degrees, right? So another way to write 60 degrees is like this. Then you subtract 1928 minutes. Okay, then do the subtraction as usual. So you get 10 2 minutes. Here you have 5. 5 minus 2 is 3. Then here you have 9 minus 9. We didn't take a 1 out of this, right? So 9 minus 9, 0. This is 40. So for R2, you have 40 minutes, 40 degrees, 32 minutes. Right? So if you learn, when you're learning, you must be able to do this, right? Otherwise, you don't know optics. This is the, you have to find this when you are doing that Snell's law. There's no way around, right? Right. So we have for R2, we have 40 degrees and 32 minutes. So what are the values we know? We know the R1 and we know R2. So if we know R2, again you have to apply Snell's law in order to find I2, right? So here you have I2. We know R1. So using R1 we found R2. Again apply Snell's law in order to find I2, right? So you can find I2. Just apply Snell's law to this surface, second refracting surface. Actually, you have to do this on your own, right? I think Okay, to second surface, I'm going to apply Snell's law. This is how you apply it. So here you have 1.5, that is n sine R2. We have value for R2, that is 32 minutes, equals outside refractive index is 1 sine I2. Now if you find I2, you have found all the angles now, right? You have found R1, R2, and now it is I2. Okay. You have to do this, right? There's no way around to learn this. You have to do this, right? The simplifications are a bit hard, but there's no way around. Okay. So 1.5 is what? 3 over 2. Sine 4032 is, you need to find that again, right? Sine 4032. So how do we find that? If you have issues with the table, let me know. Right. So what's the value? Sine 4032. Okay, sine 40. So 40 degrees, right? Then from above we need 32. We have 30 minutes. So for 30 minutes it is 0.6494. So this is for 30 minutes. But we need another 2 minutes. So for 2 minutes we have 4. Okay. You just have to add this 4 to this one. Then you can find the value. 6498, right? So you get 0.6498. Okay. Right. So this is equal to sine I2. Equal to sine I2. Okay. Now divide by 2. 0.3249. Then you need to multiply that by 3. 7, 2, 12, 14. 1 is remaining. 6, 7, 9. Then again sine I2 is equal to 0.9747. 9747. Okay, so to find I2, what do you have to do? You need to find inverse of this. So without being lazy, you have to do this, right? Otherwise, there's no way around. You have to do this, right? So for sine 0.9747, so if you refer that, the value is 77 and 4 minutes, right? 77, 4 minutes. Okay, now we know all the angles. I1, I2, R1, R2. Right? So, so in the question what they ask is simple D. That is deviation, angle of deviation. So we know that D plus A is equal to I1 plus I2. I1 plus I2 is equal to D plus A. D plus A is 60 degrees. I1 is what? I1 we found that, right? What did we get for I1? Actually this 30 degrees is I1. I2 is this one, 77, 4 degrees, 4 minutes. Then we have 107 degrees and 4 minutes. 107 degrees and 4 minutes. So this is D plus 60 degrees. But we need to find is D. So 107 degrees 4 minutes minus 60 degrees. Minus 60 degrees. Okay. So I have to subtract 60 degrees from this value. So if you subtract that, you can see 7,404 minutes. So this is the total angle of deviation. I mean angle of total deviation, right? Remember what you get here? That is 4704 minutes. So that is how you find angle of deviation. That is the total amount that the ray has deviated as it emerges, as the ray emerges. So we found that, right? Okay, in the question, the first part they ask I2, then they ask simple D. So that is everything you have to do. So in this question, you have to find like everything, right? I1, I2, R1, R2. And we applied Snell's law to first refracting surface and the second refracting surface. So we did everything. Okay. I think everything is clear. Then put a point, write down according to reversibility law of light, comma, if I1 is incident angle, I1 is incident angle, comma, I2 is emergent angle, I2 is emergent angle, I2 is emergent angle, full stop, right? Then write, if I2 is incident angle, if I2 is incident angle, I1 is emergent angle. I1 is emergent angle. So this is really important to understand the reversibility law of light, right? It is about I1, I2, and if you send the ray from the other side, then it will follow the same path, right? So we'll have the same ray diagram. So it is like this. Draw it with me. So let's draw two diagrams. So for the first one, let's say this is I1, like this, and it bends like this. Then this is I2, right? This is I2. So in this law, what they say is, let's say if you send the ray like this, and it will have this ray diagram, right? So at the next one, you are going to send the ray from this side. So it will follow the same path. That is reversibility law of light, right? Reversibility law of light. So the shape of the ray diagram will be the same. Like this, and like this. Actually, you are sending the ray from the other side, right? It will have the same ray diagram. Only the direction is different. So, so in the sentence, that is what it means, right? So if you send this, if I1 is the incident angle, always I2 is the emergent angle. If you send the ray like this, I2 becomes the incident angle, and then in that case I1 becomes the emergent angle. Okay. So they have asked many questions from this. Okay. Take this down. Okay. Done, right? Thumbs up if you are done. And if you have any issue, send me a message. You have to clearly take down this note. Okay. This is a very good note for you to refer after. Thumbs up if you are done. Noora, are you done? Noora? Okay. So I think understood, right? This is reversibility. This is very important. Uh, we can explain this using the previous example, right? So for the previous example, the incident angle was 30 degrees. Then what was the, we found the emergent angle. What was the emergent angle? That is I2, 77 degrees 4 minutes. Okay. So if this is 30 degrees, then this is 77 4 minutes. So in this way, what do we call? If you send the ray at 77 4 minutes, then this is going to be 30 degrees. So without solving anything, you can say that, right? Using reversibility law. That is what it means, right? Okay, write down, put example. This is example of the reversibility law. Write down example, then write according to the Q, capital Q means previous question, right? According to the Q, when incident angle is 30 degrees, when incident angle is 30 degrees, emergent angle is 77 4 minutes. 77 degrees 4 minutes. Full stop. Then write to the same line, when incident angle is 77 4 minutes, 77 4 minutes, emergent angle is 30 degrees. Emergent angle is 30 degrees. Then to the same line, right? Angle of deviation, within brackets simple d, within brackets simple d, is also going to be this much. So if you remember that 47 4 minutes, right? We found that 47 degrees 4 minutes. In both cases, right? So here we have the angle of deviation. This is d, right? Angle of deviation, total angle of deviation. Here also we have the same ray diagram, right? Then the angle of deviation going to be this one. So you can see this angle and this angle is equal. Okay. If you send the light ray like this, and when you send it from the other side, we'll have the same ray diagram, right? Okay. So that is the first thing you have to understand. They ask questions from, especially for MCQs. Okay. You need to understand that reversibility thing, right? Okay. Another thing you need to understand, first we'll take it down, put a asterisk mark, put a star, write down when I1 decreases, when I1 decreases, R1 decreases. When I1 decreases, R1 decreases. Full stop. Why is that? Don't have to write it. So you know Snell's law. I sine I1 equals n times sine R1, right? So from this equation you can understand when I1 decreases, R1 also should decrease, right? When I1 decreases means when you move this ray towards the normal, to this side, right? To this side, I1 decreases. I1 decreases. So when I1 decreases, this angle R1 also decreases. It is obvious from this equation, right? Not proportionally, but decreases, right? Okay. Full stop, then write this one. So, comma, R2, R2 increases. So R2 increases. Write down. R2 increases. So why is the R2 increase? Why does the R2 increase? Again, from the equation you can understand that. We know that R1 plus R2 is capital A. So from this one we saw that R1 decreases. This is a constant, right? That is prism angle. So when R1 decreases, R2 has to increase by the same amount. So the prism angle will be capital A, right? So I1 decreases, R1 decreases. R1 decreases, R2 increases. This is R2 here, right? Then to the same line, right? At an instant, R2 equals C. Write down R2 equals C, capital C, critical angle. R2 equals capital C, right? Then I2 equals 90 degrees. I2 equals 90 degrees. Okay, so I have to understand this behavior. So what did I say? I1 decreases. Okay, just understand. Remember this like a story, right? I1 decreases, R1 also decreases. When R1 decreases, R2 increases. This R2 increases. From a small value, it increases. It increases up to the critical angle. You know, just before the total internal refraction, we have the critical angle. This angle it becomes equal to the critical angle. So when that is equal to the critical angle, what happens? In the note, you need to take this down, this diagram. So at a certain I1 value, so here we have R2 and it is equal to critical angle, that is capital C. So when the angle is critical angle here, that is R2 equals C, emergent angle becomes 90 degrees, right? This is emergent ray. Draw this on the note. So at a specific I value, this angle becomes critical angle. Then the emergent angle becomes 90 degrees. So that is what happens just before the total internal reflection. Draw this one below what we write, what you have written. Okay. Okay. So if you are done, if you draw this thumbs up, you need to remember this as like a story, right? This happens, then what? This happens, then what? Like that. That way you will remember this. Otherwise, it will be confusing, right? Okay. So here, what were we doing? So we kept decreasing I1. So I2 keeps also decreasing, and R2 increases up to C, critical angle. Then we are going to further decrease, not increase, right? Further decrease I1. Then R2, I mean R1 also is going to decrease further. Then R2 is going to be greater than critical angle. So when it is greater than critical angle, what is going to happen? Then there will be total internal reflection, right? Put a point and write down. Point, write down. If I1 further decreases, if I1 further decreases, comma, R1 also further decreases. Then R2 further increases exceeding the critical angle, within brackets this happens, right? This is the requirement for the total interreflection, within brackets R2 greater than C, semicolons, total internal reflection, total internal reflection occurs. total internal reflection occurs. Okay. Then below that note, draw this again. Now there's total internal reflection, right? At a certain I value, total internal reflection occurs, meaning 100% of this ray that gets reflected like this. So when it reflected, these two angles should be equal, right? When reflection, it comes like this, then leaves like this, emerges like this of the prism, right? Here we have the total internal reflection after critical angle. I think understood, right? Draw that. If you are done, thumbs up. The answer done. Right. So up to now, I think understood, right? Okay. So you know that when you exceed, this R2 exceeds critical angle, then this ray will not emerge from this surface. So there is a certain I1 value that this happens, right? I1 value, minimum I1 value. Okay. Minimum I1 value. If you further decrease I1, then there will be no emergence of this prism. Okay, so there's a minimum I1 value. Okay, take it down. uh, this shows to emerge the ray from second refracting surface from second refracting surface I1 has a minimum value. I1 has a minimum value. Within brackets, let's call that I simple m, right? I simple m. Okay, so to practice this, we'll do a question. Write down Q. Find IM, right? Which sentence? Okay, write down this shows, comma, to emerge the ray from second refracting surface I1 has a minimum value. I1 has a minimum value. Okay, within brackets IM. Done, right? Okay, let's do a question to practice this one. Write down. Find IM for an equilateral prism. Find IM for an equilateral prism. Within brackets, this is a glass prism, so n is equal to 1.5, right? For an equilateral prism, n is equal to 1.5. Okay. So I have to understand what this IM means, right? So at the minimum value of incident angle, what happens? R2 equals C. If you want, you can draw this. So this, it is like this, right? When the incident angle is IM, at the other side, ray goes like this. This angle is capital C, critical angle. R2 is equal to critical angle. So like this, you can find IM. So for this one as well, you need to apply Snell's law. So you need to refer the logarithm book. You need to practice that, right? So without the practice, you cannot go just to the exam and then quickly get the answer. You need to practice before that, right? Without being lazy. Okay, so for the glass refractive index 1.5, for AI it is 1. You can apply Snell's law to this point first, right? Because before finding this critical angle, you can find using the index, refractive index. We know nothing about this point at first, this first refractive, but this one we know, right? What do we know? We know emergent angle, that is 90 degrees. We know that. So apply Snell's law to this point first. So how do we apply that? 1.5 sine C equals outside refractive index 1, emergent angle, that is 90 degrees, sine 90. Okay, 1.5 you can write it as 3 over 2 sine C equals sine 91, right? 1. So sine C is equal to 2 over 3. 2 goes here, 3 goes here. Sine C is equal to 2 over 3. Okay. So to refer the sine table, you have to convert this into decimal. 0.66 something, right? 66, if you round it off, 667. So you can find sine C, sine inverse 0.6667. Okay, inverse value of this one, you need to refer the table. You have to do this on your own, right? So this value or a close value less than this, right? Find 6667. Do we have 6667? We have 6648, right? In the table, we have 6648. How much 6748 means? 9, 1. So there's 19 further. We know, we want. We have 17, right? Here we have 70, we can't go for a 19. After that it is 20, right? So we are not going to 20, just go for 17. This value is 8 minutes. This value is 40 minutes. And degree value is 41. 41 degrees, right? So the inverse value of this is going to be 41 degrees 48 minutes. I'm taking time to do this because these are important, right? Really important. Okay. Okay, now we found the critical angle. 41 48 minutes. Okay. Then we know that this critical, actually R2 is equal to C, right? This is R2, but it has become critical angle now, right? Then we know R1 plus R2 is equal to prism angle. For an equilateral prism, we know that this angle should be 60, right? All the angles are equal. For an equilateral triangle, 60, 60, 60. So this prism angle is 60. R1 plus R2 is 60 degrees. We found R2, that is C, 41, 48 minutes. Then you can substitute it here. Equals 60 degrees. So R1 is equal to 60 degrees. How do we write 60 degrees? 59, 60 minutes minus 41, 48 degrees. Subtract 2, 1, 8, 1. 18 degrees 12 minutes. So that is the value of R1. R1 here, right? R1 here. So if you know R1, you can again apply Snell's law to find Im. Im. Okay, let's apply Snell's law again. Refractive index here 1 sin Im equals refractive index here 1.5 sin R1. That value we found 18, 12. Okay, sin Im equals, this is 3 over 2. Then we need to find sin 18, 12 minutes. How do we do that? Refer the table. So there we have 18 degrees. Then 12 minutes. So from here get 10 minutes. What do we have? 0.4253. Further we need 2 minutes, right? Then again comes down. For 2 minutes we have sorry, not this value. It should be 18 degrees, right? For 18 degrees it is 31. 31, 18. For 2 minutes, 6. For 2 minutes the value is 6. So 0.3124. Okay, 3124. So that's the value of 18 degrees and 12 minutes. Just substitute it here. Then divide by 2, 0.1562. Multiply by 3, 6, 18, 16, 4, 0. This value. This is sin Im, right? Then again you have to go for the inverse. Im is equal to sin inverse 0.4686. Right. You need to find a close value to that. Close value. 4686. What do we have? 4686. We have 4669, right? 4669. 86 minus 69 means 7 1. So there are 17 remaining. You need to find that from the table. I mean from the remaining side. We have 15. So 15 means 6 minutes. Here we have 6 minutes. From this one we have 50 minutes. Then the degree amount is 27. Okay. So 27 degrees 56 minutes. Okay. So this is how we find IM. Okay. So if we further decrease less than 20, this value 2756, what is going to happen is this is going to get total internal reflection. Okay. So that is how we find IM. If you are done, thumbs up. Or if you have any problem, let me know. You have to clearly understand this. Okay. Like 100%. It's better if you can do this at home as well, these questions. Okay. Nora, did you understand? Okay. Right. So you should be able to do this quickly, right? Within a short time. Just apply. So for that you need practice. Okay. So this is the only lesson that you will learn this Snell's law. Okay. So you have to practice more and more questions. Okay. Right. Then put an asterisk mark. Write down. To emerge a light ray, to emerge a light ray from second surface, to emerge a light ray from second surface, what's the requirement? R2, right, should be less than critical angle to emerge, right? Not for total internal reflection. Total internal reflection should be greater. But for emerging, at least like this or like this, if it is equal, it emerges like this, right? If it is larger, it emerges like this from the second surface. This is the requirement. Write it down. R2 less or equal to C. This is the first equation. Write down, that is the first actually inequality, right? Then below this, write, according to reversibility law, of light, comma, to emerge from AB, AB means first surface, right? To emerge from AB, write down R1 should be less than C. So this is the second inequality. right? So we can add these two, when you get a inequalities, same as equation, you can add, right? So R1 plus R2 less than C plus C 2C. Okay. So what is R1 plus R2? R1 plus R2 is capital A. R1 plus R2 is equal to the prism angle. Okay. So this is important. In order to emerge any ray, this is the requirement. Prism angle should be less than 2 times the critical angle. Okay. Take it down. From a side, draw this diagram as well. So this is emerging, right? Emerging, because we are talking about emerging rays. So this angle I1, this angle I2, this angle R1, R2. This is ABC, right? ABC. Okay. Draw this one, then let me know. If you have complete drawing this, let me know, right? So what I explain is using this one, right? So what this means is you can take this one, right? R2 less than C. If you consider the light ray going from this side, it will have this path. Okay. In order to emerge like this from the AC surface, second surface, this is the requirement. R2 should be less or equal to critical angle. Then you send the ray like this from this side. Then to emerge from this AB side, what is the requirement? R1, this is R1, right? It should be less than critical angle, otherwise it won't emerge, right? Then I just add that and prove that A should be less than 2C, right? So from this one you can understand, just below this write down this sentence. Write down requirement for emergence of rays from a prism maximum value of prism angle within brackets A max, capital A, right? A max is 2C. So A max below that, right? A max equals 2C. Okay. So if you have a prism angle should be less than 2C in order for the emergence. Otherwise it will total interreflect. Okay. Below this again, right? if n equals 1.5, n equals 1.5, critical angle capital C is 41 degrees 48 minutes, right? If you want, you can find this. You know this equation sin C is equal to 1 over n. So 1 over n means 2 over 3, right? 3 over 2, it flips. 1.5 means 3 over 2. 1 over 1.5, 3 over 2, it goes 2 over 3. Then you can find C. If you find that, you get 41, 48 minutes. Earlier we found that, right? 41, 48 minutes. Okay? So if you think about this prism, right? What should be the maximum prism angle for that, for this one? That is, let's say A max. It should be 2C, right? 2 times this angle, 41, 48 minutes. What do we get? 2 times 16, 1 is remaining. 8, there's 9, right? 96 minutes. Then 82 degrees. Just understand how I'm multiplying this. You just multiply this. So 48 times 2, 96 minutes, 82 degrees. So we know that this is correct, right? But usually when we have more than 60 minutes, we make it a degree, right? So get 60 minutes from this and make it a degree. So 36 minutes is remain this side. When you make it a 60 degree, this becomes 83 degrees. 83 degrees, 96 minutes. Take it down. So for this prism, this is the maximum prism angle, 83 degrees, right? Otherwise, there will be no emergence. All the rays will get totally interreflected, right? If you have the prism angle more than that, usually the prism angle is like equilateral prisms. So the prism angle is about 60 degrees, right? But we can design a prism like this. It's almost like 90 degrees, right? So when it is closer to like 90 degrees, at the second surface, the ray would get totally interreflected most of the time, right? Okay, take it down. If you're done, thumbs up. And if you don't understand something, let me know. Okay, below this, right, therefore, 3 dots. If A greater than 2C, A greater than 2C, none of the rays will emerge from the second surface, Okay, so you can understand there's a order, right? There's a order to this. Then you can easily remember this, right? Actually what is happening, the complete history of a ray incident on a prism, right? Then put another asterisk mark. This is another thing you have to understand, right? Write down when I1 increases, what happens? R1 increases, right? We saw that R1 increases. So then write full stop. Then R2 decreases. R2 decreases. Remember that? Why is that? R1 plus R2 A, right? R1 increases, R2 decreases. Okay. Then R2 decreases. So when R2 decreases, what happens? I2 also decreases. Write down. Uh, I2 decreases. I2 decreases. Okay. Now listen. When I1 increases, R1 increases. When R1 increases, R2 decreases. When R2 decreases, I2 decreases. Why? Again, Snell's law here, right? To the second surface, if you apply Snell's law, you can understand that when this R2 decreases, I2 also decreases at the second surface. Same. If it decreases, it decreases. If it increases, increases, right? When we are thinking about Snell's law. So finally, what has happened? Finally, what has happened? You can understand that when I1 increases, I2 decreases. That's the final thing, right? I1 increases. These happened. Finally, what has happened is I1 increased, I2 decreased. I1 increased, I2 decreased. Okay. So we can draw this in a graph. Take down this graph. If I draw a graph between I2 and I1, if I draw a graph between I2 and I1, what's the minimum angle of I1? That is IM, right? There are minimum angles than IM as well, but here I'm talking about emergent rays, right? For emergent rays, minimum angle is IM for I1. We found that earlier. So let's say for that minimum angle, we found a value for I2. Then when you increase from the minimum angle, I2 decreases. Decrease like this. Draw this graph. Okay, draw this graph. So I1 increases, I2 has decreased, right? Like this. Done, right? If you're done, thumbs up. Okay. Below this, put a point and write down. Here, rate of decrease of I2, rate of decrease of I2 is higher than I1. Rate of decreases I2 is higher than I1. Comma, then it is lower. Then it is lower. Okay. Then write this equation. D. We know that D is equal to what? I1 plus I2 minus A, right? D plus A is I1 plus I2. So we can say D is equal to I1 plus I2 minus A. Write down this equation. Then put a point and write down uh, since comma I2 initially decreases I2 initially decreases at a high rate at a higher rate at a higher rate simple d decreases simple d decreases full stop full stop then I2 decreases at a lower rate when I1 increases. Then I2 decreases at a lower rate when I1 increases. Full stop. This causes simple d this causes the simple d to increase. Full stop. At an instant simple d reaches a minimum value. Simple d reaches a minimum value, which is called angle of minimum deviation. Angle of minimum deviation. Within brackets dm, right? Angle of minimum deviation dm. Got it? Angle of minimum deviation. Right. Done, right? Right. Okay. So what I just said, I'll explain that, right? This is really important to understand the angle of minimum deviation, dm, right? Okay. So in this part, in that sentence, we are talking about deviation angle, simple d. We are talking about simple d, right? So what do we do? So there's a minimum value, that is im. We are only talking about after im, right? So for after im, it is no total internal reflection, right? Below that, there's total internal reflection. If you want, you can write it. This area is for total internal reflection, right? Total internal reflection area. If im is less than, if I is less than I1, less than im. But here we are only talking about this one, right? After im. Okay. So what do we do? So we know that for im, there's a certain value of id. Sorry, d. Okay. So now we are increasing. We are going to increase I1. Increase I1 means what? We are gradually increasing I1, right? You are changing the path of the incident ray. You are increasing the I1, okay? But the thing is, I2 does not increase by the same amount. It is according to that sign, right? Sign functions. So when you increase the I1, what happens initially? Rate in the sentence. uh, I2 decreases. I2 decreases, but at a lower rate. But at a lower rate. Try to understand this, right? Important. If you understand this, you don't have to remember anything. You know, like here this happens, right? At the first case, initially, I1 increases, right? So we are going to increase the I1. But I2 decreases not by the same amount, by a less amount, right? So if you increase this by a 1 degree, let's say 10 degrees, this decreases by like 2 degrees initially. Now what happens? This value is getting higher, right? This value is getting higher. If this is increased by 10 degrees and it decreases by 10 degrees as well, then the sum of these two values is going to be a constant, but this decreases by a small amount, so that total value increases. I1 plus I2 value increases. So when this value increases, minus A, simple D increases, right? So that happens after. Okay. Sorry. It is the other way around, right? Okay. Listen now. So we are increasing the I1, right? We are increasing the I1. These are experimental results. Okay. I1 when you increase that, I1 actually decreases by a larger amount. If you want, you can write this at a side of the page. This initially I1 increases, I2 decreases. Okay. This is a constant. So what happens to the overall expression? Overall value decreases. Then D decreases. Okay. So here that's why it decreases like this. Right. This happens at the first half. Then it comes to a minimum value which we call D min. Okay. After this point, what happens is, let's say second, I'll write the equation again. At the second phase, what happens is, I mean, after reaching the minimum angle, right? After reaching the minimum deviation, further you are increasing I1. Now what happens is, decrease of I2 is less. So this value increases now, right? Increasing value minus A, so D increases. Then the graph going to be like this. Okay. If you don't understand, refer that again. Okay. Right. And another one is, at this value, we know that I1 and I2 equals at the minimum angle, right? Because we have the same dm, you can understand that by reversibility law. For the we have a one angle, right? One angle of deviation. So if you think about somewhere here, you have two angle of, I mean, for this deviation, you have two angles. One is I1, other one is I2. So for this one, it is only a one angle, right? For this deviation, minimum deviation, it is only a one angle. So I1 and I2 should be equal, right? Okay. Just write this from a side, then draw this graph. Try to understand graph fully, right? You cannot have, you don't have to have like precise values, but if you want, you can find, but you should be able to explain this. Then you will fully understand this graph, right? Okay. Take this down and thumbs up. So if you understand this perfectly, you can answer any question, right? Any MCQ. So from the theory itself, you can understand it. Okay. You find those MCQs hard because actually you don't understand the theory clearly. You think you understand, but there are some deep facts about those, right? You have to get the big picture there. Okay. Right. Right. Again, I'll explain this. Right. So we know we are only talking about the angles after IM, right? Because we are not talking about deviation of when there's a total interreflection. There's a deviation, right? But we don't talk about that. We only talk about for emergent rays. So I1 should be greater than IM. Okay. Right. So here what happens is at the first phase, first thing we know is at the previous graph, we got whenever I1 increases, I2 decreases. At the previous case, we learned that, right? Whenever I1 increases, I2 decreases. That happens always. Here, what's the difference? At the first case, I1 increases, I2 decreases. So it is okay. But the rate that I2 decreases is greater. It is larger. So if I1 increased by 1 degree, I2 decreased by like 5 degrees, right? Okay. So the overall I1 plus I2 term actually decreases. Okay. So this becomes like a minus 4 value, right? Then there's minus a, actually not minus, okay? Uh, Initially, this rate is higher. So this term decreases as a whole. When this I1 plus I2 decreases, D decreases. That's why this decrease like this comes to a minimum value. After that, what happens? I1 increases, further I1 increases, but the rate that I2 decreases, it less. Understood? So this I1 plus I2 term increases because this increases, and it is like, let's say this increase by 5 degrees, this decrease by a 1, right? So it is 4, right? There's a plus 4 amount of a value, right? So this whole thing increases. So D also increases. This minus A. That's why after the minimum deviation, simple D value increases, right? Simple D increases. Okay. Uh, then you have to think about the reversibility law. From this graph, you can identify that, right? So there's an experiment. You have to get this one, right? So we know that from the reversibility law. Let's say this value is D1. There's a certain angle of deviation, right? D1 value. So for the same D1, what do we have? We have two I values. We have two I1 values. One value here, another value here. So why do we get that? So if this is I1, then other side I2, right? So we have a deviation, simple D. Then if you send the ray to the other side, then the incident angle is I2. From this side, incident angle is I1. At the other side, incident angle is I2 if you send the ray from the other side. But for both cases, deviation angle is, we have the same deviation angle. So that is what's shown here, right? So here you have the deviation angle, then you have two values. So those two values should be I1 and I2. Okay. So when I1 increases, you can think other value should be I2. Okay, so those values reaches like this, and at the minimum deviation they become equal, right? Okay, put a point, write down, put a point and write down when when simple d equals d min, when simple d equals d min, I1 equals I2, I1 equals I2. R1 equals R2. If I1 and I2 equals, R1 and R2 also should be equal, right? Okay, R1 equals I2, sorry, R2. Hence, the ray moves through the prism, ray moves through the prism symmetrically, symmetrically, symmetrically. Okay, you can understand that, right? There's a symmetry actually, like if a ray enters here, you know that I here, if it is I1 here, this angle is equal at the other angle as well, right? And there's a symmetry around this axis. So if it is I, then this also is I. Then this also R, this also R, right? So there's a symmetry. Uh, below write down, below write down. For other cases, there's not symmetry, right? But for minimum deviation, there's a symmetry. Write down here, comma, I1 equals I2 equals I. You can take it to be I, and R1 equals R2 equals R. So that value I'm taking a one value, right? Because same value. Okay, write down point. Put a point. Write down if AB equals BC, not equal. AB parallel, right? Parallel AC. So sorry, equal. AB side, right? This is ABC. AB side, isosceles prism. AB equals AC. AB equals AC. So if it is symmetrical, what should happen? This ray and BC should be parallel, right? Okay, write down AB equals AC. Ray through the prism, this ray through the prism is parallel to what? BC. This is parallel to BC. Okay, draw this one. This one and this one parallel, right? And it is symmetrical around this axis. So those things happens at the minimum deviation. Then there are these things you need to understand. So we know that A is equal to R1 plus R2. Okay. But here R1 is R, R2 also is R. These are only applicable for minimum angle deviation, right? So we have here 2r. Then r is equal to a over 2. Okay. Then what is the another one? I1 plus I2. Okay, another equation. Minimum, when it comes to the minimum angle, D is D mean, right? D mean. So when it is D mean, we know that I1 and I2 equal to I. I plus I. This is 2I. Then from this one you can understand I is equal to D mean plus A divided by 2. Okay, so we have at the minimum deviation, we have value for I R and a value for I. Right, take them down. Then at the third scenario, third one you have to consider is Snell's law, right? So for the Snell's law, we know that 1 AR sine I is equal to n times sine R. Sine R. Here we are going to derive an expression for n. So n is equal to sine I divided by sine R. So n is equal to what? Sine I means D min plus A divided by 2. Sorry. This equation is important, right? You need to remember this. Sine A plus D min divided by 2 divided by sine A over 2. You just have to substitute these values. R is A over 2, I is D plus A over 2. You need to remember this. Okay. Okay. If you have an issue, let me know. Okay. To practice this, we'll do a question, right? We'll practice to practice this. I put Q. Write down find D min. Find D min for an equilateral prism. For an equilateral prism made of glass. Made of glass. Within brackets, n equals 1.5. Right, you can find that. Equilateral prism means we know capital A, right? Capital A. It should be 60 degrees. Okay, find that. If you want, you can use the last equation, or else you can derive that. I think deriving that is easy. Not deriving, I mean from the beginning you can start. So we know A is equal to 2R. If it is equilateral, A is 60 degrees. So you know that R is what? From this you can find R first. Okay. Then you need to find I, right? I, incident angle. In order for the minimum deviation, there's a certain incident angle as well, right? To get that, you need what? Snell's law. Because we know R, for the ray we know R, then you can find I, right? If you know R, you can find I using Snell's law. There's no way other way, right? You need to go for the Snell's. So what is that? 1 sine I equals N sine R. Sine R means sine 30, right? Sine 30. Found R. Here N is given, that is glass, 1.5. Or you can write it as 3 over 2. 3 over 2 sine 30 means half, 3 over 4. So sine I is equal to 3 over 4. Then I is what? Sine inverse 3 over 4. This is a value we don't know, right? So we have to refer the table. Sine inverse 3 over 4 means 0.75. Okay. Find 0.75 inverse. Just going to be the value for I. You need to practice these, right? If you at least practice later these examples, you will have the enough practice. You might, right? Okay. You need 0.75. Find that in the table. What do we have? 0.75. What we have is 0.74990. 7490. We need 10 more, right? In order to make it 0.75, you need 10, right? So above 10, there is a 5 minutes. Above this one, there is 7490, there's 30 minutes. Then the degree value, find it from here. 48 degrees. So I is what? 48 degrees 35 minutes. 48 degrees 35 minutes. That is the I. So we know I and R now. Then the third equation, we know that D plus A is equal to what? I plus I, that is 2I. D, we need D mean actually. This is 60 degrees. I is 48. 35 minutes times 2. 2I. 2I means this one. Right. Multiply by 2. So you can understand 35 minutes times 2 means 70, right? I'll just put 70 minutes for now. It's fine, right? 48 times 2 is 96. 96 degrees. But when you are writing the answer, you know you can get 60 minutes, which is a 1 degree to degree side. So it's going to be 97 degrees, 10 minutes is remaining. Okay. That is not the answer. This is D mean plus 60. Okay. To get the D mean, you need to subtract 60 from this one. So when you subtract that, 97 minus 60 means 37. 37, 10 minutes. Okay. You need to do this accurately. Okay. For that, you need to practice. There's no other way. Okay, there is a one more part that we have to discuss. Then it will be all the things regarding prisms, right? Right. If you have taken this down, thumbs up. So I want you to before doing MCQs, there are not a lot of MCQs. You can refer page through book or something. Then do past paper MCQs, right? Regarding prisms, there are not a lot of MCQs there. First thing you need to do MCQs, okay? So when you are doing the MCQs, before doing them, just do these examples first, right? Then do the MCQs. You will have a solid understanding of this. So without doing questions, just because you understood the theory, then it is not going to be useful at the exam, right? You must do questions, otherwise the, these theories and everything will be forgotten, right? You must do questions at home, okay? I'll give you the explanations for those. Otherwise, it will be useless. Okay. Okay. Write down this topic. Uh, using prisms. Using prisms as reflective. Reflective surfaces. Reflective surfaces. As reflective surfaces. Okay. Write down, since below that, write, since n equals 1.5, n equals 1.5, capital C approximately 42 degrees. C approximately equals to 42 degrees. Okay. Uh, therefore, prisms, therefore prisms with this one, write down 45, 90, 45. You can understand this one, right? 45, 90, 45. Prisms like this, isosceles prisms, isosceles right angled prisms. Isosceles, right? Right angled. Okay. So 45, 45, 90. If you want, you can draw it some. If you want, isosceles right angled. Can be used for reflection, not refraction, reflection, right? Right? Okay. So here we are going to get the total internal reflection. This is better than mirrors, right? Better than mirrors. Because for mirrors, we don't have like 100% reflection. So, but from this one, you can have the 100% reflection. Okay. Okay, this is how uh, first case, write down 1, right, by 90 degrees. So we are going to turn the ray by 90 degrees. So we place the isosceles prism like this. You can draw this with me. This must be isosceles, right? Isosceles. Otherwise, these angles are not 45 degrees. Okay. So isosceles 90 degrees. So think about a ray like this, comes like this. It doesn't deviate here, right? It no perpendicular to this surface, so it moves like this. Then what should be this angle? If this is 45 degrees, this is 45 degrees, then this also 45 degrees, right? 45. If it is 45, it is greater than 42, which is the more than critical angle. Critical angle is 42, right? This is 45. So definitely there's going to be total internal reflection. So the 100% of the ray gets reflected actually, total internal reflection. So you can see 90-degree deviation. Okay. So this is the first case. Take it down. Then we can do this one using this method as well, right? If you use two prisms like this, one like this, another one like this, both are isolates 90. Okay. Here also I'm putting two, right? Two. Okay. Two rays. Comes like this. One arrow goes like this. Everywhere there's total internal reflection, right? Because greater than 45. This should be isolates, right? 45. Then another ray goes like this, comes like this. Again, two arrows. So if you get these two rays from an image like this, the image, what you will see here will be upright. It is not inverted. Image is not inverted, right? This is better better where. So when you are in like a battle tank, right? You don't have to put your head above the lid of the tank, right? You can see from here. So if the tank is like this, lid of the tank is like this, you can see top of the land. I mean top field of view, right? Okay, understand? This is the structure there. Yeah, in submarines. Yeah. For submarines as well, same case, right? So this is the simple structure. This is actually better than glasses. I mean mirrors, because 90% is a clear image, right? So like that. It is the another advantage is it is not inverted. It is upright. So if you see like a inverted image, then it is not good, right? Okay. So at these cases, there's 90-degree deviation. Okay. Then second case, write down by 180. Write down by 180 degrees. So for we get a isosceles prism. Draw this with me, right? Isosceles right angle prism. Send a ray like this. Another ray, two arrows. Then total internal reflection. But this is double arrow, right? Double arrow. So if you have an image like this, I mean object like this, image of that object would be inverted. Here it gets inverted, right? Okay. It turns 180, but also it inverts. So that's the second case. Let's think about third. If you are done drawing, thumbs up. All of these are used in like telescopes, those like what do we call microscopes. But we don't learn this. But in practical cases, so if these are used, right, in all those applications. Right. Third one, write down without deviation, without deviation, without deviation, take in an inverse image, without deviation, take in an inverse image, right? So let's say, so for some reason, I can't think of an example, but for some reason, let's say you need to invert that. From optical instrument, you might get a parallel beam that is inverted. Then if you send that through in this method, I haven't explained that, then you can make it to the correct orientation, right? Like this. So let's say you place the prism like this, isolates. Ray comes like this. What happens? Normal. It refracts like this, right? Then another ray. Then again it refracts into the prism, right? Then this ray gets totally interreflected at this point, right? Because it is greater than 45. That is double arrows. Then again this one. Then at here there's a refraction. This has refraction as well. At the refraction, this is double arrows and this. So you can see it has inverted, right? It has inverted image. So if you, let's say you already have you can draw this. Let's say you already have a inverted image from here. From when you have a simple telescope, you will learn that you get inverted images, right? But if you send it through here, you can actually upright it because it inverts again. Inverts again means it gets the correct orientation. Okay. So this also is useful. Right. Talk it down. Thumbs up if you're done. Here there's some reflection as well. Okay, thumbs up if you're done. Right, right, okay. So that is regarding the prism, that is all we are going to discuss, right? So the next class, we'll be talking about lenses, right? Which is really important, lenses, okay? It is a somewhat of a lengthy part. So the thing is, regarding prisms, there are practicals, right? There are practicals. So within a one day, I cannot do all the practicals and the theories, all those, but I'll send you the recordings of the practicals. You must watch them, right? But there are a bunch of practicals. You know, spectrometer. That is a somewhat of a large practical, but you must watch that, right? And take a note, and you have to send me that. Spectrometer practicals. Then there are practicals regarding optics. Okay. So the largest number of practicals regarding like a subunit, it is from prisms actually, right? There are many practicals from prisms. So as I remember, I think it is like about 4 practicals, right, regarding prisms. I'll send you the recordings, but you have to watch that, right? Watch that, and you need to take a note on those practicals. That is the first thing. then you have to do the MCQs as well. And if you have an issue, you can ask me actually. Right. So within that week, before you start in lenses, you must do that, right? Otherwise, you won't have a solid knowledge on this if you don't do those questions and the practicals. So that is where you can increase your marks actually. Just understanding the theory is not enough. You have to practice for those questions and the experiments as well. That is where you increase the mark, right? That is how you go for A actually, right? Okay, we'll see you next day. And if you have any notes, you can refer the notes regarding lens. We'll start lenses next day, right?